Right now, somewhere in Brazil, there's a patch of grass nobody would ever look at twice. No fence around it, no sign, no indication that anything is happening there. But 8 meters underneath your feet, something built a city, hundreds of chambers, miles of tunnels, highways for traffic, ventilation systems, underground farms, waste facilities, nurseries, a fully functioning city that took 40 tons of soil to build. Built by something with no hands, no blueprint, no architect, and a brain smaller than a grain of rice. Think about what it takes for humans to build anything. Before a single wall goes up, you need architects who spent a decade learning their craft. Engineers calculating load, surveyors reading the land, project managers coordinating hundreds of workers all reading from the same blueprint. It still takes years. It still goes over budget. And you still need someone at the top who can see the whole picture or the whole thing falls apart. Ants have none of that. Not one ant has ever seen the nest as a whole object. Not from above, not as a finished shape, not as anything. And yet they build the same city on opposite sides of a continent. Same layout, same depth, same systems. Every single time for 50 million years. So how? When scientists in Brazil wanted to actually see inside one of these nests, they had one option. Pour 10 tons of concrete into the entrance holes. Let it set for a month. Then excavate it like an archaeological dig. 10 tons of concrete just kept flowing down and sideways, filling spaces they had no idea were there. What came out of the ground stopped the scientists cold, 8 meters deep. That's a 3-story building underground, hundreds of individual chambers, each built for a specific purpose. Tunnels organized into highways and side roads. Ventilation shafts. Waste rooms kept physically separate from the nurseries. Fungus farms at the exact right depth to maintain the right temperature. The researcher who led the excavation called it the ant equivalent of the Great Wall of China. And the ants who built it moved 40 tons of soil to do it, grain by grain, with no idea what they were building. So let's start with the obvious question. Who's in charge? The queen, right? She runs the colony. She directs the workers. She has the plan. That's what everyone assumes. It's completely wrong. The queen digs exactly one chamber in her life. One alone. At the very beginning, when the colony is nothing but her and a handful of eggs. She seals herself in, lays her eggs, and after that, her role in construction is finished forever. Every tunnel that follows, every chamber, every system, every highway, built by workers who have never received a single order from anyone, ever. There is no foreman, no manager, no one coordinating anything. And this is where it gets genuinely strange. In 1959, a French biologist named Pierre-Paul Grasset was watching termites build their mounds for hours, and he noticed something nobody had ever put a name to before. No termite was telling another termite what to do. No termite was following a plan. Each one was only ever reacting to what was already in front of it. A termite picks up a grain of soil, laces it with a chemical scent, drops it somewhere, that's it. That dropped grain isn't a message to anyone. It's just a slightly more attractive spot for the next termite to drop its grain. The pile gets bigger, the scent gets stronger, more termites drop here. Not because anyone told them to, because the pile itself told them to. No one decided to build a wall. A wall just became the most likely place to keep building because building had already happened there. Grasset called it stigmergy, from the Greek. Stigma, mark, ergon, work. Work that leaves a mark that tells others what to do next. The structure isn't designed. It accumulates. Ants run the exact same system, but leafcutter ants take it further than anyone expected. For years, scientists assumed that somewhere inside a tiny ant brain, a decision was being made. I will dig a chamber here. I will put the nursery next to the farm, some version of a plan. So researchers tested it. They built a simple forked tunnel, 2 identical branches, then placed a pile of larvae at the end of just one of them. Nothing else. Just larvae. The ants dug more than twice as much soil from that branch until it had widened into a rounded chamber. A perfect nursery. But no ant decided to build a nursery. The larvae attracted traffic. Traffic needed room. Room got dug. A chamber is not a decision. It's a side effect. Now here's the part that should genuinely stop you. These nests have working climate control. The fungus farms inside them need near perfect conditions. The exact right temperature, the exact right humidity, low carbon dioxide, drift even slightly out of range, and the fungus dies. The colony dies with it. So how does an ant with no thermometer, no concept of temperature, manage this? Researchers found that leafcutter ants can sense carbon dioxide with a sensitivity that scientists compared to a pit viper, an animal that hunts in total darkness using nothing but temperature. When a chamber drifts out of range, no ant fixes it. They just pick up the fungus, pick up the larvae, and move everything to a better room. Thousands of individual ants all independently sensing the same thing and making the same local decision. The net result is a colony that regulates its own temperature without a single ant knowing what temperature is. It gets weirder. A nest this size produces enormous amounts of CO2, millions of ants breathing, millions of fungus cells metabolizing. Without airflow, the nest suffocates. Scientists found a working ventilation system running through these nests, hot air rising out through some shafts, fresh air pulled in through others. A loop, passive, continuous, self-sustaining. Nobody engineered that. The tunnels were dug blind for other reasons. The physics did the rest. The nest breathes because the architecture accidentally behaved like lungs. But there's still one question left. If no ant is giving orders, who decides which ant digs, which one forages, which one does nothing at all? A Stanford biologist named Deborah Gordon spent her entire career on that question, watching harvester ant colonies in the Arizona desert for decades. What she found broke the last assumption anyone had left. Nothing decides. Each morning, a small group of ants called patrollers leaves the nest before everyone else, walks out a short distance, comes back. If they come back, the foragers go out. If they don't come back, nobody goes out. No announcement, no order, no danger signal, just the rate of contact. How often are you bumping into a returning ant? High rate means the world outside is safe. Low rate means it isn't. Gordon found this logic running everything. An ant's decision to dig or forage or rest isn't assigned by anyone. It comes from who it happens to bump into in the last 5 minutes. A colony of 1 million ants organizes itself through accidental collisions. Now here's where it gets personal. In the 1990s, a computer scientist named Marco Dorigo built an algorithm based on exactly this. Simulated ants wandering a network, leaving virtual pheromone trails, no controller, no blueprint, just the same rule ants have always used. The path that gets walked more gets reinforced more. That algorithm now runs inside real shipping networks, telecom infrastructure, traffic routing systems, solving optimization problems too complex for any single human engineer to solve by hand. We didn't invent that. We found it underground and copied it. Here's what this all actually means. For 100 years, we assumed intelligence looked one specific way, a single mind, a central controller, someone at the top who can see the whole picture. Ants prove that's not the only way. No ant in that colony understands the colony, just like no neuron in your brain understands what you're thinking right now. Each one just fires when the signal around it crosses a threshold. The thought is a side effect, not a plan. The blueprint was never in anyone's head. It was in the space between them, and they've been building it perfectly for 50 million years, long before we figured out how to draw one.